Lesson 8, investigating the graphs of polynomial functions, part 2. So repeated factors we're going to talk about. Now think about this. When you have a perfect square quadratic where it's just x minus 2 squared, what's that parabola do? Do you remember? What's the parabola do when it's a perfect square? Like in terms of what's the graph look like? Well, yeah, it's a parabola, but there's something about it being a perfect square. What's that? No, it's not centered. It has one intercept. It bounces. So when you have x minus 3 times x minus 3, it hits the 3 once, right? It's that situation where your zeros is, remember, your options for parabola are 0, 1, 2, right? So look. Correct. It's hitting it, but it's hitting, that's fine. Good. It's hitting it twice in the sense of that's what gets you to the correct degree, but you don't count it twice. And that can happen here. So you can see this cubic only has 2 x-intercepts, technically, because it has a bounce. So that means it has a repeated factor. Okay? So here's the repeated factor. See that? X plus 1, x minus 3 squared, so it hits the 3 twice. Like Aiden said, but really that's 1 x-intercept. We don't count it twice. That's why we call it real non-equal. Okay? So the polynomial has 2 factors, one of which is repeated. This means that the function has 2 distinct zeros. See? It only has 2 zeros, one of which is repeated. The factors are x minus 3, which is repeated, and x plus 1. The zeros of the function are 3 and repeated and negative 1, so we just write 3 and negative 1. The graph of the function has 2 x-intercepts. We say the function has 2 distinct zeros of negative 3 and 1. The x-intercept is negative 3. We know that's just normal. Or sorry, the x-intercept of negative 1, that's just a normal 0. The x-intercept of 3 is repeated. They've said this like 3 times now in 2 seconds. Okay. And the repeated 0 of 3 is said to be a 0 for multiplicity 2. So this is kind of what we want to add today. Multiplicity. So this means that it happens twice. The multiplicity of 3, the 0 there, is it happens twice. So that makes sure that that can help you understand that this is a cubic rather than a quadratic. Because if you just saw 2 zeros, maybe you think it's a quadratic, right? But it's not. It's still a cubic because it has a multiplicity of 2. So you can still see your multiplicity should add up to 3 because it's cubic. Right? If you have all the zeros for this one. Well, that's the most it can add up to. Okay? Because it doesn't have to cross. We know that. Okay? All right. The multiplicity of a 0 corresponds to the number of times a factor is repeated in the function. In this lesson, we'll investigate how the multiplicity of a 0 affects the shape of the graph of a polynomial function. In order to do this, we have to define the following terms. Okay? So let's talk about these terms. Tangent. You guys remember what tangent means? Okay? Tangent means one time through. So a polynomial graph is tangent to the x-axis at a point where the graph touches the x-axis and does not go through it. So that's like essentially it only hits at one point. Okay, so it means it bounces. Okay, so think about the real definition of tangent, which I like, is if you have a graph, and you do this in calculus, you find tangent lines for slopes. You have a line that goes through that exactly one point. That's called tangent. So then think about your tangent line is simply the x-axis here. It's just hitting at one point. Okay. Points of inflection. So this is where things are inflected from concavity. Now, cubics tend to do this. A polynomial graph has a point of inflection on the x-axis if the graph changes concavity at a point on the x-axis. So see how it comes through. It's going concave down. See how that's down? And then turns. And now it's doing a different curve. That's concave up. This is concave down. Just think about if you continued it, what would it do? If you continued it, what would it do? So this is concave up, concave down. Okay, so then here too, concave up, concave down. So if it switches from concavity, switches the concavity, then you have a point of inflection there. Any questions on this stuff? You're going to have a whole unit in calc if you do that on graphing and using these things with derivatives. It's kind of cool, actually. Okay, in this lesson, we'll consider only polynomials where the leading coefficient is 1 and negative 1, so we're not going to do 3x cubes or stuff like that. Okay, all right, so let's look at this one. Consider the polynomial function x to the 6th, oh boy, minus x to the 5th, minus 11x to the 4th, plus 13x cubed, plus 26x squared, minus 20x, minus 24. Cool, they get to me factored, that's nice. Okay, so it's factored. Yeah, it's actually, what? Yeah, so it's factored though, it's x plus 3, x plus 1 squared, x minus 2 cubed. Okay, So it wants us to look at it on the calculator first. Okay, so let's go and put this in the calculator. I think it's probably easiest to put this in than that, but do whatever you'd like. So let's go and put it in the calculator real quick and see what we see. We'll use the window they gave us. So negative 551, negative 100, 120. So let's do that real quick here. So we got negative, so let's go negative 5, 5, 1. And then it says to use negative 100, 100. Yep, negative 100, 100 for your y min and max, and then a scale of 20. Okay, and then we're going back to our y equals. We're going to clear this out. I'll just put what they have, I guess. X to the 6th minus x to the 5th minus 11x4. Ah, gosh dang it. I always need to clear that, sorry. X to the 6th. I'm doing it again? Oh my goodness. Jeez. All right, we're going to go the factored then. That's what it's telling me. It's telling me to do the factored. Thanks for telling me that, Lauren. I'm just going to keep on trucking. All right, x plus 1 squared, get down. There we go. And then we got x minus 2 cubed. Yeah. Okay, cubed. And then get down. Okay, so graph. All right. So the one thing I want you to notice is this is a degree of 6, right? Check this out. 1, 2, 3, 4, 5. So it changes direction 5 times, right? Now think about that. Parabola, degrees of 2, they change direction how many times? Once. Kind of think about that, okay? So the degree of the polynomial kind of signifies how many change of directions you can expect, okay? And then look what's happening. We got a bounce, and then we have a weird thing happening here. Right, you got a concavity there that's changing, okay? So let's go ahead and we'll minimize this for a second. Let's go ahead and just generally sketch it on the left here. We got okay, roughly like that. Okay, complete the chart below. State the zeros of p of x, their multiplicities, and where each 0 is. So 0, number 1, we have is, yeah, negative 3, thank you. I was looking at the wrong table. Say negative 3, good. And what's its multiplicity? 1, right? And so you see it just goes right through. Okay, passes right through. Okay, next one, negative 1. Multiplicity, 2. What's that do? Tangent, we're going to say tangent, but yes, bounces. Tangent to x-axis, so that means it hits it once. Remember, tangent means hits once. On which one? Right, because it goes completely through. This one bounces off of it. Yeah. Okay, and then the last one there is 2 and multiplicity of 3, and we can see this is the new one. This one, by having multiplicity of 3, it switches concavity there. So it's coming concave up, or sorry, concave down, it switches to up. Okay, so switches concavity. Okay, so we call that point of inflection. Okay, so we're investigating, it's a point of inflection. Okay, and then again, we already made this observation on the previous example. If you add our multiplicities, what do you get? You get the degree. So it just says degree of this is 6. If we add the multiplicities, we get 6. Okay, we just got one more. One more. Any questions, guys? Is there anything that's just blowing you away? Okay. All right, let's look at this one. X to the 4th Okay, x to the fourth here. Let's go ahead and put the calculator together. I'll see if I can do this correctly for once. All right, so the window, they want us to change it to negative 6, and they want us to go negative 150 to 100. So we're at 100 already, and then negative 150. And they want us to scale 20 still, which we have, okay. And we want to go here, so it's clear. And we're going to go, okay, x to the fourth, get down, plus 2x cubed, get down, minus 15x squared. Okay, and then we have minus 32x, and we have minus 16. Okay, so there it is. So this one, look, what I was pointing out to you. Change direction 1, change direction 2, change direction 3. What's the degree? 4, right? It's just one behind that. Okay. Also with the 4, you can kind of see it's a little bit more, I'd say more symmetric. It's not completely symmetric, but a little bit more. Okay. So it looks like this one, if we're looking at this graph, 1, that looks like a bounce, right? And then 2. So like we have 2 zeros and a multiplicity of 2 here, so that's 1, 2, 3, 4. See how I'm counting that? Because this is a bouncer, right? So we're expecting that to be a multiplicity. So when we look at this here, I think it's negative 4 and 4. Yeah, so negative 4 and 4 are zeros, and it bounces at 1. So I'll draw this here, just here. Bounces at negative 1, sorry. Negative 1 bounce. Okay, it's a little bit lower here. Okay, so there's your 4. That's your negative 4. This is happening at negative 1. So your zeros are negative 4, negative 1, and 4. So we see, like I told you, our multiplicities of these ones are 1s because it goes straight through. Okay, this one's a 2 because it bounces. Okay, so that means that here, this one, what we call is tangent to x-axis. Okay, this one just straight through. And then this one, same thing. Okay, straight through, straight through. Okay, and so then it just wants us to do these last two pieces here. So the degree is 4, and the multiplicities were still 4. So make those connections. Okay, and then it wants us to write this in factored form. That's not a problem. So we know it's going to be x plus 4 times x minus 4, and it's going to be x plus 1 squared. That's it in factored form. Okay, all right, that's all we got.